Hello everyone. This video is my scientific programming homework video. I will explain my questions which are included in my homework PDF. I have two questions in this homework. These are second and fifth questions. Fifth questions is also there. Depends on my student number. I have these questions. Then I understand from the second question, we will write two kinds of method code. The first will be not always optimized. The second one will be optimized according to steps given in the question. Generally, in this code, I create an array, place its elements, try to find an element in the array, and proceed its similarly. So first of all, I will describe the non-optimized code. To create the array, I used a struct array. It was item 1 in this question. I defined the number of loops. It corresponds to n. I observed that as the number of loops increases, the time increased accordingly. Next, I placed an element inside the array, and I did this with help of the for loop. It corresponds to item 3. And I also created another array. I pushed array, a created array before into it. Then from the array I created, I found elements that are bigger or smaller than 100, and I performed this operation using the find method. This operation corresponds to for item. Then I created a full matrix. In other words, diagonal matrix. A full matrix takes up too much memory space. It corresponds to item 6. Then with the optimizing method mentioned in the beginning of the questions, I called method n10, and I defined at the beginning. As a result of this operation, I run and time on the program. And now we can see that running is 0.867 total time. Then let's look the optimized code. And now let's look optimized code, and why I will explain that. I didn't write in a different code in this code than the other one. I just tried to follow the instructions given in the question. If we examine that one by one, first of all, I used clear command. This corresponds to item 2. I have delayed tools that are not used in memory, so I made the code run faster. Later, I used a numeric array instead of the struct array. This corresponded to the first item in the question. A numeric array runs faster than struct array because it takes less space memory. Later, I placed the element inside array, but there I made loop by vectorizing it. So again, the code worked faster. This corresponds to item 3. Later, I found the numbers greater and less than 100 with logical indexing in the array. In case it were not optimized, we didn't this with the find method. The operation here corresponds to the fourth item. Then I create the sparse matrix. I called sparse matrix in optimizing tool by n. This process runs faster than full matrix. The reason for this is the sparse matrix takes up less memory space also. And let me run again with run and time. You can see here clearly we have 0.862. If we compare this cost, we can clearly see that the optimized version works better. In addition, since we don't do clone in this code, obtain advantage in time. And now we will continue with fifth question. Now we will continue with the fifth questions. For 5E, as given in the starter code of our homework, we got this line. I write here. In the option A of the fifth question, we were asked to apply the contour slice command. 9 on the YZ plane and 1 on the XY plane. Correspondingly, I have defined a variable below. The number you put in the square brackets doesn't change anything. It's up to you. Then I use the compose command. The explanation of this command is called camera position in MathWorks. In fact, this command that allows us to see the figure like this. And then for display axis outline, I wrote these two lines. The figure looks like one given in the example. Let's look at the figure. You can see that the figure looks like the one given in the example. Now we will continue with 5B. In the part of this question, a question asked us to make a diagram by using the slice command and gave the numbers corresponding to coordinates. I used a slice command in the first line of our code. Then I added a color bar to make a graphic similar in the example. The line under the color bar is, I think, not necessary command. It's just the colored solid line. Then I used a compose command again to help draw our graphic. I found the value we given in this command by trying it completely. Then let's see the figure. You can see that this figure is similar with given in the example. This is our 5C questions code. In the option C of the question from us, questions wants us to draw the surface normals of the f and g functions. It says that we can do this with surf norm method. In code, returns a peak function evaluated at the points specified by x and y. Next, I define the f function exponentially and hold the graph. Then if you want, you can add a color bar for surface pilot, but I didn't write that. And we can see the graph now. The graph is also similar with the example figure. This is the code for our 5D question. In the option of the in 5 question asks us to draw the functions f and g given in the previous question with the slice method. First of all, I using the mesh grid. I assigned the values in the example here because the graph values must be the same. Then I defined the f and g functions in the slice method. This slice method takes several values. The value of v here allows us to show our function 3 dimensions. I mentioned the hold and hold off method in the previous question. It allows us to keep the previous function and show the graph of the other function on the figure. And now we can see the figure. I think this figure is not so similar with given in the example questions, but I tried to do it. Then we can continue with 5e. It's the solution of the 5e question. In the case of A, we have been asked to graph the values given using the isosurface. So first I defined the values for isovalues. Next I created an array of length times with isovalue 1. I specified this array for the nested isosurface. Each isosurface will be an element of array. Then I created a for loop for isosurface. Since there are 6 isosurfaces, the loop's number of loops in also from 1 to 6. Inside the loop, I added the isosurface. I created the array. I made isosurface creation with the isosurface function. Then after I finished adding isosurface, I made a coloring and positioning. I have specified as many colors as the number of isosurface with HVS. With perspective, I determined the position and appearance of the chart. And now we can see the graph. As you can see, this figure is also similar with the example figure. It's the end of my presentation. Thank you for everything.